All right, welcome back. This is section 7.4 in the book, Exponential Growth and Decay. And last video, we talked about implicit differentiation, and I did tell you that it would come into play. So what we're going to talk about today is the law of exponential change. And the first thing we need to know, exponential change, the first thing that we need to know is that exponential growth, by definition, means that the rate of change is directly proportional to the amount. So you could think of this in terms of a bank account. Your rate of change is your interest rate. Your interest is directly proportional to the amount that you have present. And we can write this as dy dx. Well, let's go dy dt because this is going to change with time, is equal to ky, where k is your constant of proportionality. And if you haven't seen this before, directly proportional means that something is equal to ky. You could have inversely proportional, which would be k times 1 over y, proportional to the square, k times y squared, etc. But here we've got directly proportional. So what we're going to do here is now we're going to go ahead. We've got a separable equation here, and we're going to separate it and take the derivative. So we'll multiply by dt to get the differential. dy is equal to ky dt. We want the y function to be on the side with the dy. So we've now got 1 over y dy is equal to k dt. Notice, separable function. Over here, we've got nothing but y's. Over here, we've got nothing but, well, we've got the constant and the t's. Doesn't really matter where the constant goes. This makes it easy. Taking the derivative, the antiderivative of both sides, we get that the natural log of absolute y is equal to kt plus a constant. And notice that I didn't put a constant on both sides. If you're wondering about this, jump back and rewatch the original video. Constant on both sides could be combined into one constant, so we're just going to have one constant. So what do we got now? We've got that the absolute value of y is equal to e to the kt plus c. We can fiddle around a bit here. Sorry, my nose is itching a little bit. Fiddle around here with the powers, and we get that absolute y is equal to e to the kt times e to the constant value. Again, hopefully you see the exponent rules there. But e to the constant value is just some value a, and if we call this a sub naught or a sub 0, this is the amount at time 0. And if we think about plugging in t equals 0, e to the 0 is 1. And so at time 0, we've got e to the c, which means that absolute y becomes a sub naught, my initial value, times e to the kt. And since I've got an absolute value, that means that a sub naught e to the kt could be positive or negative, which means that y equals plus or minus a sub naught e to the kt. This is our law of exponential change. We have growth if k is greater than 0, and we have decay if k is less than 0. So we're going to want to highlight that, make sure we make a clear note of that. I'm going to ask my students to go ahead and do exercise 11 in the book. And I'm going to make this a super short video because the next thing that we're going to do is just power through a whole bunch of examples. So we'll stop here and we'll see you back with the examples. Thanks for watching.